All right, so recording is on. Today we'll be going over our third homework, and we'll be, sort of talking about how everyone experienced Plotly or Shiny rather, and we'll and then we'll introduce a bit of homework 4 and what's going to be expected um, as we're moving on to Python. So unfortunately, I'm behind on the grading. I still owe you guys homework 3. So that is coming. I should be able to get that to you guys this week. And in terms of Shiny, I don't have um, everyone's homework looked at, so I'm not able to really go through like what the pain points are. So in terms of everyone's experience, like were there any pain points, and what sorts of things were difficult, etc. with Shiny? So there was some debugging that was going on. Any specific experiences or um, anything that people noticed? All right, so I'll just get into the homework then. Mostly intuitive, cool. Yeah, there's a few. Okay, Aaron asked in the chat if is there a smooth getting a smooth animation, and he noticed it was difficult with Google Viz. Do you mind explaining what you were looking at? Is that like just within Google Viz, or was that Shiny thing that you were noticing?
Sure. I mean, I use Google Viz in conjunction with Shiny, and
Yep.
I guess my problem was I was doing calculations, or there were calculations happening behind the scenes in between each frame.
Mm-hmm.
When I was running that in sort of an animated mode, and I would think in a live situation, I would just have all the frames saved ahead of time, and so everything could be played back smoothly. But as things stand now, it's a bit clunky.
Mm-hmm.
And I don't know if other people attempted an animation with a slider, but yeah, it was clunky for me.
Mm-hmm. Okay, and in terms of the animation, so I'll have to take a look at what both of you guys did. But in terms of the animation, like this wasn't the motion charts, was it? Or was it just an animation on like a different style chart?
Sorry, I need to actually review my code again, but I wasn't using a standard Google Motion chart. I mean, I was just basically programming the slider to move automatically with a play button, and you can change the rate at which it moves, but it seemed like the calculations behind the scenes were taking a while. So I couldn't really do a fast refresh because the map wouldn't refresh fast enough. It wasn't able to do the calculations on time.
Ah, okay, I got it. So you were using Shiny controls over Google Viz? Like, was the slider a Shiny slider?
Yes.
Or was
Yes, you got it. It was a Shiny slider.
Mhm.
Thank you.
Okay, yeah. Thanks for the clarification there. So, and there was a play button as well, or was it just? Okay, cool.
Yep.
So yeah, that's something that even if you are using a framework like Shiny, there's you're going to end up with the sort of web development headaches that you would regardless. So if there are things like you're trying to just do too much with sort of a single action, and again, I'd have to take a look at I'll take a look at your guys' examples and see what ended up happening there, but um, when as like what I found is as you're using frameworks like this, it's I mean, it's great that so much is abstracted away, but there's also a kind of the danger of that is you almost you like a user of something like this or of Dash in Python, you're like you're used to sort of being able to work in an exploratory way, perhaps in RStudio or a notebook, and when you are building an app, you need to think about what you know what you're like particularly working on. So this seems like it might just be a it might just be a limitation of Google Viz, but this is just something to keep in mind. Like I've worked with like in my professional life, I've worked with clients who they would try to make a database call with every dropdown, and things like that. It's like you still need to think about these sorts of design issues. Cool. And I have some things with. I'm seeing some questions here with subsetting. So I could talk a bit as I'm going through my example, and we're talking through it. I'll go through like how subsetting was happening. I The specific example where so Marco, I'll have to check out your specific code, but I seem to remember running into um, a similar issue, but for some reason the exact context is escaping me at the moment. But I remember every so often, I'm doing if I'm doing subsetting in dplyr, I need to. Oh, actually, was it Marco? Was this subsetting with dates? Or actually, I think the data type of the yeah, I'll check and I'll check when I'm going through the homework. So I'll take note of all of these, but it's like that's one issue I am remembering now that dplyr sometimes doesn't play nicely with dates, and I've had to resort to just using traditional brackets when subsetting there. Cool. So really, okay. I see Alex mentioned everything he tried with filter didn't work. Um, so I'll go through my code and we'll sort of talk about different strategies in dealing with these these different ways of filtering. Yeah, and then like I mentioned, we'll go through some Python stuff as well. So we ended up, this module was a bit less, because we're sort of introducing Shiny, these questions are a bit more straightforward. And it's, more about really, having the, sort of getting started with a sort of more web development framework, working with R. So for the first question, we're looking to compare rates across different states and from particular causes. And so in particular, we're only looking at the 2010 data, and we're looking at some different at the crude rates across all states. So let me just run my app here. So the approach I took, and I saw a lot of people, handed in separate separate apps. That's totally fine. Each question was its own unique thing. I just ended up combining them on this tabbed view for simplicity's sake here. So so basically here we're just looking at the this is a view of different is the right one. Yeah. So we're looking at like different different crude rates across these states. So here we're sort of really taking that minimalist approach and relying on, in this case, Plotly to really display the states here, so that you could sort of so that you could look at it, in this sort of sparse way, being able to pick the chapter. And in this case, state is only affecting question 2, but I just reused the sidebar here. So to go through what was happening here, and I'll go through, so just in terms of, rough estimate, how many people used reactive expressions? Cool. I see a lot of people did, some people didn't, but in this example, it didn't really matter. And there was, and in terms of how reactive functions work, there was like it is kind of weird. So yeah, there is. So it looks like it was a weird issue happening with the date. Because we're dealing with years, I cheated a bit and just allowed these to remain ints. So I was just simply filtering based on sort of the int year. So, but that is a limitation with dplyr. I actually don't know what I haven't really checked their GitHub to see if there's something that Hedley's doing about that. But it's but yeah, I've definitely run into that issue before. So in terms of what I was looking at here, so I ended up using a reactive function to filter by ICD chapter. And then I ended up, so basically for the first question, we're looking at, we're not really dividing by state. We're simply looking at disease type. So, I kind of wanted to attach, kind of make sure that everything is flowing in the correct way, because I am doing everything in the same app. I wanted to make sure that, the sort of filter I'm using for question 1, when you're additionally filtering by state, which question 2 requires, you're sort of adding that onto the existing filter that we had from question 1. So it's just in the Shiny tutorial, I went through sort of the logic behind that, and you could kind of see that it's really coming to it is coming to play with this example. But it's a fairly straightforward. It was a fairly straightforward task. So totally fine if reactive functions weren't used. So that's what's happening here. And then I saw this was one of the issues that came up in the discussion board, that it's kind of unintuitive at first, that that essentially the reactive function returns a function. So, when you are, and that function itself returns the data frame that's being filtered. So, and that's something that it's, I actually don't know how they could really, if there's a way that, like within Shiny, there could be smarter errors, but you end up with type errors, and it's, it could be pretty confusing for debugging. Like I remember that's been a common sticking point in the past, and seems like that was the case for at least a few people this time. And a lot of times you could, sort of inspect each of these, sort of individual elements. Like basically, when and this is something that you'll get into, when we're beginning to get into JavaScript, and we're working with debugging in that way, that basically you could add things like print. So I could say something like, if I were checking out this selected data, I could add something like print selected data. And actually what would happen if I did that is after I run the app, it would display sort of the function itself. So actually, if I save that and reload this app, I think it's type you'll have to do. It's type of, isn't it? There we go. So yeah, it's giving this this type of as closure, which so we're looking at this object here, and even that's I'm not too sure what closure is there, but it's essentially this enclosed area of code here. I thought it would just come up as a function, but basically it's when if you were expecting a data frame there, which is if you're making an error like this, one would expect that to be a data frame. You're trying to filter and it's not working. That's this is a way of sort of working with this type of debugging, and this is something that is usable in other frameworks. So I'll sort of quickly introduce Dash towards the end of this meetup. But with Dash, it's very similar. You're using Python print commands, and you'll be looking at those in your terminal. And I'll go through that, but that's going to be more sort of the advanced homework for. And when we're getting into JavaScript, it's going to be the same thing. The command in JavaScript is console.log. And these are just strategies of, when you are building apps like this, a lot of times it could feel like it's all or nothing, and it's really difficult to sort of debug in that context. And one strategy is to, sort of take a look at your variables and try to see what's happening with them. So that's just a bit on some common debugging, and basically what I'm doing here is just doing some like here we're filtering for 2010. I could have put actually I couldn't have put that in the reactive function because for question 2 you need other years. So you could see how I'm kind of adding that additional filter that is required for either question 1 or 2 within the output functions. And in this case, I was using Plotly, so I'm just rendering Plotly and looking at a scatter plot of crude rate by state. So that's where so that's just sort of what I'm looking at for plot 1. So really for question 1, all that's really happening is this output here. So any questions on that before we move on to question 2? Cool. So for the second question, we're just looking at whether particular states are improving their mortality rates faster or slower than the national average. And actually, I'm sorry. Before I go into question 2, for question 1, were there any other? Does anyone else want to mention sort of an alternative visualization type that they used to look at this? given the, given it's a categorical, yep. So maps worked really well because that's, we're looking at states. So those of you who chose maps, which library? I know, I think Marco mentioned you used Google Viz. ggmap, cool. Cool, yeah, and maps were definitely a, like that would be a way to sort of view that by states. Things like bar charts would work as well. I just kind of chose to go more minimalist with dot plot, but you could really, there were lots of options there. It's more about sort of working working around working around Shiny. Yeah, and I see some people used different packages. Cool. So yeah, let's move on to and actually one thing that this is bringing to mind in terms of the maps. If people are using R, I actually haven't. I've only recently come across it, but I think it's in ggplot geom_sf. I've just come across this because it's something we're looking at to eventually add with Plotly. But have people come across this geom type in ggplot? Yeah, I'll have to. I'll try to see if there's a vignette or something like that that I could share in the announcements. But it was geom mapping. I'm forgetting the exact terminology, but geom SF is supposed to be R's answer to, or like a more ggplot friendly way of working with like a choropleth map. So it's essentially, and yeah, I'll try to find the vignette, but it sort of lets you take custom shape files, come up with kind of your rubric. So so the thing about choropleth maps, a lot of packages come with like built-in support for states, support for whichever levels of geography. But a lot of times, one of the sort of frustrating issues with these sorts of problems is any kind of non-standard geography. You may you may have the need to try to and usually it would mean sort of resorting to something like D3 or leaflet. Actually, not leaflet for choropleths, but more something like D3. And geom_sf is supposed to simplify you have a shapefile and you have polygons, and each of these polygons have a value mapped to them. It's showing up as a choropleth. So it's meant to simplify that. So that might come in handy for final projects if people are using Shiny and need to have custom shapefiles there, because usually the only other option is to pretty much dig into the weeds of D3 and bring in your shapefile and parse it using using another tool. So I'll try to find that vignette there, but that's just something to note. So getting back here for question 2, we're just looking, comparing the states to the national average. And for that was fairly straightforward as well. So here, this is allowing users to make 2 selections, select different disease causes, and also pick out different states. So here, this is kind of made in a more exploratory sort of way. Letting users letting users pick. Did anyone use like another option here would have been sort of using small multiples if we wanted to get that sort of comparison? Did anyone end up using using something like that? Something that where you're kind of viewing everything at once in a paneled sort of view? Yep. So yeah, that's another sort of example, kind of strategy that you could have used for this particular question. But again, for this homework, the questions were meant to be a bit more straightforward because it's more about kind of getting that first stab at building an interactive app rather than working through the kind of the sort of visualization questions that we were really doing before. Um, so that's it for the Shiny homework. Any other questions about Shiny? In the Shiny tutorial video, I mentioned a bit about concepts like server side, client side. So it'll be worth it to kind of discuss that a bit, since this is something that applies to things like it'll apply to Dash, it'll apply to D3 when you're using that as well. Shiny is pretty good at kind of dividing it up and making it easier for a non-web developer to still grok these concepts. So here, you have your UI and your server, and really, really just the way to think of this is, you have two sides to a web app. You have the client side and the server side. And the server side is essentially anytime data is leaving the user's computer and is making a query with some external database and then coming back with information. Like that's really sort of utilizing the server side of the web app, and it can get pretty nuanced. So to sort of use Plotly visualizations as an example, so here when I'm so you could sort of tell because it's in the server.r that when I make a change on the drop downs here, I'm sort of I'm utilizing the server side. I'm running an R script that's filtering a data frame and returning new data and plotting it out for me. But Plotly itself also has different, has interactivity. So here you could see like the and Google Viz as well. When you're using tools like this, you have the more you're able to sort of hover over these things. For a lot of Google Viz, like for some of it, it uses Flash, and and for that, it's that's kind of a whole other beast. So I don't really want to get into that, but just sticking with more straightforward examples, something like Plotly. When we're hovering over these values, do you think we're using the server side? And if not, kind of explain what your thinking is. anyone have any thoughts? I'll wait a bit if people are typing. Okay, so we have 1 vote for server side. Client. 2 votes for client and UI. All right, so we're about even. We're about even with the votes here. So in this particular case, the answer is that it's using it's using the client side, and it's something like this. It's this is really getting more into the weeds of web development, but I just wanted to bring it up as an example that unless you know that it's sort of happening on the server side, it may be a bit opaque how something is happening in a more complex sort of web app. And with Plotly itself, we actually have go into some drop-down examples here. But even if you see something like drop-downs or you see some sort of control, it's it's not guaranteed that it's going to that it's going to be sort of client side or server side. So something like this, it's pretty like the interactions that we're seeing is all happening on the client side. If, for example, I were making I were making a pull here, and I were using so if I were using kind of a something else to to run a model, I were using an API that did something like that, then that would be sort of going to the server side. So it's just something to keep in mind, when you're working with this, and kind of just another thing to kind of appreciate what you have with these sorts of tools. Abstracting away all of that and being able to have access to a language as powerful as R on the back end, and being able to sort of use that for operations that you're doing. So that's just sort of something about JavaScript, that a lot of times JavaScript is only happening on the client side, and for if someone is a web developer, a lot of times they're not even touching the back end. It's all being used as services, sort of a black box that something goes in, output comes out, and that's really what's happening on the front end side. So any more questions on just these general web development concepts? And again, like, it's obviously this isn't a web development class, so this is all in context of using these more data-driven tools. But it's good to just have kind of have an idea of what these are referring to. And of course, these sorts of skills are very useful, depending on what you guys decide to do with what you're learning here. So it's there is definitely some sort of a space there, kind of in the intersection of this kind of web development and data science. So with that, I'll just go into first. I'll just go into a few of the discussion points, and we'll talk a bit about what we were discussing over the previous 2 weeks. So basically, the last two concepts, these were a bit softer, and as I was as I was going through all of these, like Tufte, really sort of has these individual points that he really touches on, but he will, a lot of times, like different things will kind of overlap, and especially with, like I was sort of using all three of his books as source material for this, and looking at all of them, if I tried to go through every chapter, that would definitely begin repeating like repeating different kind of the same concept. So a lot of it's sort of this is getting to kind of a blurry line between data visualization and almost design in general when you're for information design. Kind of thinking of there being a design problem of there's information that needs to be imparted. What's the best way to do that? So, so for the first week, aesthetics and technique, this was a bit more just about about the examples, and there were a lot of really interesting examples that were coming in terms of sort of looking at this conceptually as you have something that could be told in block of text, and how much more concise you could be by providing a visualization of some sort. And the one common theme that I noticed in a few of these posts was that there's a lot of times, like in the comments, like people would be critiquing different points, and it's that sort of drives home the point that there is still a trade-off between concision and content. So it's there's when you are moving to data visualization, like in the toy example that I included in the discussion post, where it's something like that, there's very minimal information lost, just simply because you're using a more efficient. There are efficiency gains, but once you kind of reach that sort of efficiency frontier, you end up with a trade-off of, if you want to provide more information, you're going to have to use use more ink, essentially. So that's really one common theme that I noticed as people were discussing these. But again, this was more this particular topic was more example driven, so there weren't really kind of more general themes I was really able to see there. And then for the second one, again, this was sort of less related to traditional visualization, and there were some interesting insights. So multiple students kind of touched on pictorial instructions as being a way to break across language boundaries. So there was I forget who posted it, but it was the IKEA example, which is kind of famous for they don't want a manual with tons of different languages, so they sort of make it as based on the pictures as possible. And I believe it was Sharon who mentioned the Hajj sort of instructions. So like when Muslims make it to Mecca, you're coming from different language backgrounds, and this is an easy way of sort of providing that information. And then there were a few just examples that I thought were worth noting. First of all, that Judd posted the MBTA visualization, which is just really cool. And this I noticed as really blurring the line between the more traditional sort of data visualization concepts that we were talking about, and the kind of storytelling aspect of it. So something like this, it's not I found that a lot of the examples were sort of looking at more data driven sort of data-driven journalism examples where it's more about, you have text and you have the visualizations, and there's like especially outlets like 538 or Upshot, they really combine it so that it's one cohesive thing and it doesn't look like separate things. But here, like, this is way less of like, there's not really an article component at all, but it's still just so narrative in terms of what you're able to see. So being able to hover over and see kind of the summary on the left hand side here, and also seeing the and who was it? It's like, this is based off of a Mary diagram. So this is actually based off of a famous example of looking at Paris trains, which this is something where it's really pretty specific to this particular use case, but it's just a very elegant way of visualizing it. And then what was the other example? Yeah, the other example, I saw that blurred this line where Walt mentioned Sankey diagrams. And these are sort of looking at flows of information. So it's is in a similar way. It's and I believe someone else mentioned the Napoleon marching through Russia example, which is another famous older visualization. That's sort of an older example of a Sankey diagram, but it's it's kind of a singular concept. It's a singular visualization type, but it's way more narrative than something like a just a bar chart or a line chart, where a lot of times there needs to be there still needs to be some additional context to really get that narrative behind it. So did anyone else want to add anything about from the discussions? Feel free to chat or speak up. All right, so I'll see if anything gets put into the chat there. But otherwise, I'll just move on to Python. So, and I believe I asked this in the beginning, and sort of prepared that we are going to be using Python. In this case, it is going to be Jupyter. So, does everyone have Jupyter set up? Has everyone at least toyed around with it a bit in previous classes? Cool. I guess more importantly, if anyone hasn't, mention it in the chat, and we could or email me offline, and we could sort of take that offline and make sure everyone's set up. So basically, this is sort of moving on to a new kind of form of displaying information. Notebooks, like within Python, that's kind of the a standard way of doing data science with Python. It's mostly going to be notebooks, and it's interesting in that it kind of combines the display of information with the so here, let's get into the Hudson River example here. It kind of combines the it blurs the line between the sort of content creation, how you're exploring, how you're sort of producing the information, and the display of the information itself. So like, I at least know personally, when I'm working in notebooks, you kind of start out with a messy notebook that only you really understand, and then if it either you keep it like that and you're essentially using it as an IDE, or it's you kind of fine tune it and make it something that that can be sort of shared with others. And it's a really like notebooks in particular, like as they become more and more popular, like I just think it's a really going to become a very powerful way of kind of technical people sharing information amongst each other. So, kind of combining that, like with our studio is more tailored to the production side, and then you have things like R Markdown, which really moves you into the sort of display side. So that's just kind of what's happening with the notebooks here. And what so the data that we're looking at, this is enterocounts, which is a type of bacteria at different locations in the Hudson River. So here, this is just sort of utilizing a lot of the features of a notebook style environment. So you could see I apologize. Hopefully that's going to stop. I hung up on them, but my Google Voice, hold on. Apologies about that. I had Google Voice opened, and that derails what I'm doing here. So in terms of the notebook, and I'm sorry, I thought I heard a microphone go on. Does anyone have a question? Nope, someone just turned on their microphone. Okay, so the notebook, like this example that I posted, it's using it's using a lot of features of a notebook. So things like printing tables, which it's really good at. You have a pandas data frame, and you want to preview it. It kind of shows it in a nice framework, and then you could sort of display the table. And I see a question in the chat. Marco mentioned that the Python environment is a bit confusing. Yeah. Okay. Yeah. So Marco, when you say one-time cleanup organization, like what do you mean by one time? Do all. Like, are you just saying it's I guess like just to sort of take a more general view on that. Yeah. So yeah, everything together. It's this is just kind of as you're working professionally, you'll like you'll see a lot of people sort of fall into R Python. It's and like it really it's partially just what you get used to. It's like for Python there is like I actually prefer Python for sort of data frame manipulation and sort of I like kind of having the like particularly web scraping I like doing there. And then for R, I kind of fell into that for more model building and sort of using because a lot of these models are just in the base R packages, rather than using scikit in something like Python. But it's something that's more based on just how you're sort of how you're working with it. Yeah, and the yeah, it's the documentation could be clearer. R just has phenomenal documentation, and the pandas documentation can sometimes be difficult, and especially moving from something like dplyr. It's there's a lot that is that is different than what you're seeing. Yeah, pandas is there's Yeah, pandas can be tough. So a lot of this will be. I believe it was just 602 that you guys have had exposure to Python. Did anyone use Python in any other classes? Yeah, 620. What's that again? That's business. Oh, that's Professor Bastian, right? Yeah, or web analytics. No, okay. Yeah, like I actually prefer Python to like using Beautiful Soup, like doing web scraping stuff like that. Um, so yeah, some people have like varying degrees of experience with Python. Luckily, this is after this we'll move on to um, something that probably no one has experience with, but it'll like after this module we'll move away from Python. But it's just try to keep an open mind and try to fight through the sort of the documentation. Like in terms of general tips, a few things I've sort of that really made pandas work better for me is if you ever come across it, looking up like the apply function, like pandas has its own unique way of dealing with either plier, and I will provide links. I don't. These should just be in the documentation, but I'll put an announcement out with a few links that perhaps could be used. And there's also the I believe it's the guy who created Python or created Python created Pandas, but it's doing data science with Python. That's the Wiley book that I found most useful for getting around pandas. But just in terms of general tips and tricks, like sort of as you're seeing how aggregations work, like try to take note of apply functions and try to draw parallels to the plier, like more plier than dplier, because plier is a bit more flexible in terms of what you're able to do in the R ecosystem. But it really lets you, it'll hopefully, like at least for me, that really clarified things. And also and also with pandas, just one thing that that once I realized it, it kind of made some things a bit clearer. But in pandas, more so than R, your row indices matter a lot. So you'll notice, you'll notice this if you're doing merging or joining. You'll sometimes end up with wonky results because it's really going by like the indices are meant to be more meaningful than you're used to treating them in R. So that's just another thing to consider there. So I'll try to look up. I'll look up those links and I'll provide a few just in terms of those kind of best ways of dealing with that. But aside from that, and then and I'll also provide a link to another link I'll provide is .ix, .loc, and .iloc, because it's those will make your filtering and subsetting so much easier. So that's and that's sort of a bit more on the basic side, but I'll post that as well, because it's like I just remember as I was learning this, like you start out with just sort of simpler indexing like this, and then once you're moving on to more complex indexing, like a filter, sort of filtering, you weird things happen. So it's so I'll provide a link for that as well. But this is just sort of going through, what you're able to do in a notebook. So a lot of times, like if you are looking, you're able to just display a data frame, and a couple of the questions they'll be asking about, they'll be asking for that. So, part of it is going to be kind of massaging your data frame to, or massaging your data into a format that that you could, that one would be able to view it. Um, and then another another frustrating thing about Python is there's no real analog to ggplot in Python. R really has it's really built around ggplot. Ggplot is really well developed. They play really nicely together. With Python, there's never really Python's a general purpose language, so there's never been a kind of visualization language that, aside from Matplotlib, that has really been with it, from the ground up. And even Matplotlib, it's still all of this is one side of what you're able to do with Python. Python you could just do anything with. So it's kind of disjointed. The visualization ecosystem. You have Matplotlib and a few languages that are based on it. So Seaborn is essentially a wrapper around Matplotlib, and so you could see a few Seaborn examples. Like Seaborn is probably the closest to something like ggplot, where it just has good defaults and it has all the visualization types that you would need. But it's a bit, kind of has a bit different syntax when you're plotting. And then because we are working in a notebook environment, notebooks can get very sophisticated. So when we were working with Shiny, the plots like VegaLite and Plotly. Like Plotly has sort of a purpose-built wrapper, which itself is just a great visualization package within Python. So on this level, it's replacing something like Matplotlib with VegaLite. It's similar where you're utilizing the notebook environment. And it's, you kind of think of it in a similar way to R, where when you plot it, it's showing up in the viewer instead of the plot window. These are, with the notebook, it's all sort of, rendering in HTML. So it's not really that much of a leap to render things that are natively JavaScript in a notebook using these Python wrappers. So because it's so disjointed, libraries like this can be more utilized as your main graphing package, whereas with R, it's more about ggplot because it's just seamless with the environment there. So that's just a bit about the visualization landscape of Python, and then a few more things I wanted to note. There are these are called IPy widgets, and these are and you don't need to do any of this for the homework. I mentioned Dash, and I'll get into that. But that's going to be sort of an extra credit option for homework 4. But IPy widgets are meant to be integrated in the notebook environment. So you could think of this as being in service of the notebook as a way of sort of communicating technical concepts. You have your notebook, you have the code there, and this sort of adds an additional kind of layer of interactivity. So just kind of going through how these work. It's like a lot of the widgets, like it used to be a bit more complicated, but with this .interact, it's been made pretty straightforward in terms of you're just pretty much working with a function. But this is almost like a mini Shiny within your notebook. So here, like the display, it's being dictated by the notebook, but it's similar logic to what we were seeing with sort of Shiny. So here, like you could see kind of looking at frequency and amplitude. And in this case, it's just using, matplotlib. There are ways to use it with other libraries, but it's it's just easier to kind of show it off with matplotlib. And similarly, just another example using using my GoTo. And then, shouldn't be using .ix anymore. But this is just sort of showing how you're, plotting different things based on what is chosen. These two notebooks should be in the CUNY widgets might not be, so I'll add this one to the course GitHub. But the Hudson River example is in the lecture 4 folder in GitHub. Tala just asked about where you guys could access these. So that's widgets, and I'm running out of time, but I do want to just briefly touch on Dash. So as an extra credit, I wanted to sort of have you guys have the option to use Dash. This was actually recently put out by Plotly, and it's essentially a standalone web app development framework. So, in short, it's pretty much Shiny for Python, but it's utilizing Flask, so it's actually utilizing the existing Python web development ecosystem. And I'm sort of running out of time here, but just to quickly show, how something like this works. So, I would recommend going through the tutorial. Like, it's pretty short and should give you a pretty good intro to Dash. And it's very much and Dash is like you'll notice a lot of similarities to what you were seeing in Shiny, where you essentially on your server side you have a function, and the function is what's sort of returning new visualizations. So something like this is kind of the Hello World Dash app, and this is, so here you could see like it's pretty much just changing what you're putting here in a text input. So not utilizing graphs just yet, but kind of going through what's happening. And when you install Dash, so basically here you could, I'll just make this a new app here. So I could do something like this and save, just save it in downloads. And the way to get an app run locally, so I believe I mentioned this in the announcement, there's, this is, officially released, but it's still early days. So the deployment is a bit beyond what you guys would be learning for this particular class, but it's but just in terms of running it locally, you pretty much have your app there. You could access it using your terminal. So making sure I'm in my right environment. So when you run a Dash app, you'll see this this show up here. It's running on this is just my local IP, and all you need to do is go to your local host colon 8050. By default, that's the port that it's using, and you'll see your app here. So again, this is totally extra credit. It's, this is meant just to give those of you who want to delve into an alternative to Shiny the chance to do that. And then, this is the tutorial. So yeah, that's these are just two other options and two other ways that using the widgets and using Dash, like these are two ways that the Python ecosystem is kind of catching up with what you have with Shiny and there. Um, so these are just a few things to keep in mind. Any other questions before I let you guys go? Yep, and this was Joseph. This was mentioned that that homework 3 wasn't graded yet. I'm still working my way through those. So yeah, apologies for that, but it'll be posted shortly, and I will post the recording as well. I think I might be behind in posting a few of the recordings, but all of these are being added to not GitHub, YouTube, and I'll just post the links there. Anything else? All right. Thanks a lot, and hope everyone has a good night.